Hey guys, this video is about sequences of transformations, or you'll also hear me call it composition of transformations, which is when we are using two or more transformations that are combined to form a single transformation. I've already graphed triangle XYZ for number 1. You'll notice I made a little bit of a mistake, but here we go. So we had X at -3, 7. We had Y at -2, 1. And then we had Z at -5, 2. So we've got this triangle here. We are performing two separate transformations on these. So we're going to do one and then the other. So we need to be doing a reflection in the x-axis and a translation. I'm going to do the reflection first. So I'm just going to take my highlighter and draw in that line of reflection so it's easy to see. And then what I'm going to do is I'm going to pick my first point and I'm going to reflect it, and then I'm also going to translate it. So this is one of the ways that we can do this. So let's pick Y. I picked Y because it is the closest to the line of reflection. So if I reflect Y over the x-axis, it's going to end up here. I'm not going to label it. I'm just going to leave it there. And then I'm going to perform the second transformation, which is going to be a translation. Let's see, it looks like we're moving to the right 9 units and then up 2. So I'm going to count to the right and then up 2. And this is where Y prime ends up. And then that looks like it is at the point 7, 1. So now that I've got Y prime moved, now I'm going to do Z. So that would go down to here, and then I'm going to count over. And up 2. And that appears to be at the point 4, 0. And then X was at -3, +7. So then I know that it's going to flip to -7. And X prime ends up here. I did forget to label Z prime, and then I'm going to draw that in. So there is my new one, and X prime is at 6, -5. So I'm just taking each one of them. I don't necessarily need to connect these intermediate points. If you wanted to, you could kind of use dotted lines, like a dashed line, to connect them if you really feel like you need to. But to be perfectly honest, when I did these, I did not connect that middle shape because I was performing both transformations on one point at a time. So that's one way that you can do this. I want to show you a different way that you can do it, which I'm going to do on the next page. This next one actually is easiest to just go one at a time. So we're going to do that. This, I haven't shown you this before, but translation along a vector, the first number tells you right or left, and the second number tells you up or down. So for this first number, since 7 is positive, that means we're going to be moving right 7, and then 5 is negative, so it's down 5. So it's just another way to write it. I don't love it. It won't show up on your test, but it shows up here. So we're going to translate first, and then we're going to reflect. So let me plot our first point. -1, +6. -1, +3. And -6, +6. So there we go. Now we are going to first go right 7 and down 5. So it really doesn't matter which point you start with. I'll start with G just because that's the first one. So right 7 and down 5 ends up here. And then we have a reflection. So our reflection is over the line Y equals -3, which is going to be this line here. So again, because we're doing one and then the other, I translated G, and now I'm going to reflect it. and it ends up right here, and that's going to be G prime, which appears to be at 6, -7. Let's do H next. So that's right 7 and down 5. And then I'm reflecting it over this line, so H prime is going to end up here. And that is at +6, -4. And then I. And then again, we are going to reflect it over, so it should end up down here. Here is my final triangle, and I is at 1, -7. So I just performed I performed my translation first and then immediately into my reflection to get to my final triangle. Okay, let me show you the other way that we can do this. And I've already completed this problem, so I just want to show you. So for number 3, for this one, we were performing a translation. So we were going to the right 4 and up 10. And then we were performing a 90 degrees counterclockwise rotation about the origin. So one of the things that you could do for this, you can see I wrote right 4 and up 10, which would be +4 to x and +10 to y. Then for 90 degrees counterclockwise rotation, when I'm rotating 90 degrees, my coordinate notation is -y, x. So you can see what I did is I wrote my original points. So I had P, Q, R, and S. So P started at -1, -3, so I wrote that out. And then I performed my translation to that point. So I added -1 + 4 to get 3, and -3 + 10 to get 7. So that was my intermediate point for P. And then I went ahead and performed the 90 degrees counterclockwise rotation. So the -y, x. So that took 3, 7 to -7, 3. Which means P prime, right here, was at -7, +3. So you could perform your transformations to the actual points here, and then this final column is what goes in your final answer, and that's where the final shape shows up. So that's another option that you could do, is to just kind of list them out. Not all of them will be easy. For example, the last problem that we did when we had to do this reflection over the line y = -3, there's no easy coordinate rule for that. So then it's easier to do it this method by like going one point at a time and doing one after the other. But if you're just dealing with translations and your reflection is an easy one to do, or especially if it's a rotation where we know what the coordinate rule is, I would recommend doing it this method.